First, of course, we want to talk about the failure. Partial success of Boeing's Starliner mission. So only one day after the capsule's landing, Boeing's CEO was fired. Coincidence? Then the successful launch of China's Long March 5 rocket. What does the launch of this rocket mean for China's future space program? We'd also like to talk about Venus again, because Venus is always not getting much love.
Now the Parker Solar Probe is set to do 2 Venus flybys, one in 2020 and one in 2021, potentially collecting some highly interesting data about that fascinating planet. And then lastly, of course, Mars, because we all love Mars. Now the European Space Agency has committed to a fascinating Mars sample return mission that could bring back samples from the red planet as early as 2031. We think someone else will have brought back some quite larger samples by then. So stay tuned for these highly interesting space news.
In our last episode here, we've already talked about the Starliner launch on the 20th of December, where the capsule wasn't able to reach the ISS. We explained how NASA was trying to paint this obvious failure in a positive light, and also that they wouldn't have been so friendly if the same error had happened to SpaceX. Now we want to analyze two things. Was it really only a minor software bug that led to this failure? Or is there more behind it? And how is this connected to the firing of Boeing's CEO, Dennis Muilenburg? This poor guy was after all fired and only got a leave package of some tens of millions of dollars. Life can be really brutal for CEOs. This poor guy must be really suffering right now. In any case, the media of course tries to spin the whole story as if the CEO leaving Boeing has only to do with the 737 MAX disaster, where after 2 fatal crashes with hundreds of people dying due to a too rushed release of the plane with buggy software, now the plane is on production stop. But we think Muilenburg leaving Boeing also has a connection to Starliner's failure, because there seems to be a bigger problem at play here. Both failures, one much worse than the other because it cost a lot of human lives, have to do with fundamental engineering problems rather than simple software bugs. An awesome viewer of ours, who is an embedded systems programmer and therefore has some detailed insight, wrote a highly interesting comment, detailing how it wasn't only a simple software bug that had led to Starliner's anomaly, but that there was some fundamental flaws in the whole engineering process of Starliner in order for such an error to occur. As he perfectly explained it, typically rockets have 3 computers and a voting system, so that if one of the computers disagrees with the other 2, it can be assumed to be malfunctioning and be ignored. Now, if the time had been set wrongly with one of the computers, the other 2 would have disagreed and ignored the computer with the wrong time. The only way that all 3 computers could have the wrong time is if the act of setting the time was done only once for all 3, or worse yet, if all 3 used a common clock. In other words, one huge problem that this little problem reveals is that whatever redundancies were designed into the system, they were defeated by a poorly thought out, non-redundant time-setting protocol. So this basically means that we are talking about such a fundamental error that the whole engineering process at Boeing must be absolutely broken.
This probably has to do with a corporate culture of management overkill, which by the way seems to be a worrying trend these days. I worked at the European Patent Office myself for a few years, and I can tell you it was the exact same there. A lot of management overkill, where the management has actually less and less clue on what problems the people are actually working on and have no understanding of the technical intricacies of the job. And at Boeing, management has no freaking clue about the technical intricacies and engineering requirements of the products they produce. For them it's mostly flip charts and some nice PowerPoint presentations, because on PowerPoint everything always works. Isn't that amazing? Now, back in the 60s, the big companies were efficient and achieved amazing breakthroughs because engineers used to be in higher positions who understood the technical details of the company's products, contrary to our time. NASA is the best example of this. What they achieved in the 60s was amazing because engineers were in positions of power who understood the technical intricacies of the job. So it really seems that this is much more than just a simple software bug. It seems that fundamental things are going wrong at Boeing, and we really hope that NASA will be wise enough not to let Starliner fly to the ISS with humans on board, because else lives might really be endangered. Now let's just hope that NASA will not give in to political pressure to push the Starliner launch as fast as possible, despite those huge problems. We personally really hope to see the crewed flights for Starliner massively delayed after the failure to dock with the ISS, and we hope that SpaceX will dock first. Now, of course, NASA will try to delay SpaceX as much as possible and let them do parachute tests over and over and over again. But we think that despite this, SpaceX will be able to reach the ISS first in mid-2020 with their Crew Dragon capsule before Boeing Starliner. And what is happening meanwhile in China? Because hey, we must stay true to our Chinese propaganda. We get paid by the Chinese government. Well, China had the launch of its Long March 5 rocket, which after a core stage engine failure back in 2017 underwent a 2.5-year investigation and redesign effort. So after being grounded for such a long time, it now had finally its launch on the 27th of December, successfully deploying the Jixuan 20 satellite into its designated orbit. And this is such an important milestone for China because the Long March 5 is the very same rocket that will also launch the 2020 Mars mission and the Chang'e 5 lunar sample return mission. Now, it has a LEO payload capacity of 25 metric tons, so it is in the same class of a Delta IV Heavy. And it will also be the rocket to build the Chinese space station, which is currently scheduled to be completed in 2022. So this rocket is extremely important for China's future space plans, at least until 2030, until the much more powerful Long March 9 is ready. Because this behemoth with a 100-ton LEO payload capacity is actually intended to bring the first Chinese taikonauts to the moon probably around 2030 or the early 2030s. Now, we will of course in any case continue to keep a close eye on the developments of the crewed Chinese space exploration program.
Then we also want to talk about two interesting Venus flybys of the Parker Solar Probe in July 2020 and February 2021. The probe has a plasma detector, which is primarily used for its solar mission of charting the solar corona and magnetosphere. However, it can also be used to learn more about the interaction of solar wind with Venus' atmosphere. How fast is Venus losing atmosphere to the solar wind? Or does Venus have pockets of residual magnetism, like Mars has? All these questions could be answered with the help of the probe. We always like to mention things that are going on with Venus, because we feel this planet is just getting too little love, just because it's an insanely hot hellhole of a planet that would instantly crush and fry a person on its surface. But over the clouds, the conditions are actually quite friendly. Moderate temperatures, 1 bar atmospheric pressure, and 90% of Earth gravity. That would be ideal for building floating cloud cities, as envisioned in this NASA rendering here. And maybe one day in the very, very far future, we might even terraform Venus. But for that, we of course need insanely advanced technology, giant space mirrors, and the capacity to remove gigantic amounts of carbon dioxide from the surface of Venus. Actually, we might even do an episode about that.
But now to our other favorite planet in the solar system, apart from Earth of course, which gets much more love than Venus. Mars, of course. So recently, the European Space Agency has committed to a sample return mission to bring back rock samples from the red planet in order to once and for all hopefully solve the mystery if there are bacteria still living in the soil of Mars. Because you know, back in 1976, the life detection experiment aboard the two Viking landers actually returned a positive signal. However, the results of this experiment are actually still debated until this very day. Now, what is fascinating about this mission is that it would actually involve the Mars 2020 rover to be launched to the Red Planet next year. This rover would then collect samples and store them for at least 6 years. Then, a sample retrieval lander mission will be launched, again by NASA, which will deploy a lander and a European-built Fetch rover as near as possible to the landing site of the Mars 2020 rover. Now, the Fetch rover will collect samples from the 2020 Mars rover, drive back to the lander, and this lander will actually have an ascent vehicle which will then carry the rock samples back into orbit. Then, an Earth return vehicle launched by ESA will enter Martian orbit, rendezvous and dock with the sample capsule, and then, after safe storage on board, go back into an Earth transfer orbit. Now, of course, the sample capsule will have a heat shield, so upon reaching Earth, the capsule will re-enter Earth's atmosphere unharmed and land somewhere in Utah, according to current plans at least, where then, if everything goes well, the samples will be collected and then analyzed. Now, this in itself is a very fascinating and very amazingly thought out Mars sample return mission, especially because it involves the Mars 2020 rover. However, the time frame for this whole endeavor is a bit problematic because the samples are expected to return to Earth by 2031.
We think that by 2031, another sample return mission will have been conducted. With this thing here, it's funny that all the government agencies have plans to let some probes do some stuff in 10 to 20 years. Whereas our boy Elon already wants to land gargantuan starships on the Moon and Mars in the 2020s. So it might really be that there won't be any need for this Mars sample return mission by ESA if the SpaceX Starship timeline will indeed hold true. Because we assume that by 2031, we could have already seen Starship landing on Mars with humans on board. It's funny how SpaceX seems to be light years more ambitious than government-funded space agencies like ESA. But hey, better than nothing, we guess.
So what do you think about Starliner? Was it really just a minor software bug, as some would want to make us believe, like NASA propaganda? Or are there some fundamental engineering problems at work here, as we and some of our smart viewers are suspecting?
We are really curious to know your opinion in the comment section. And we are really always very grateful for your comments, because we are learning so much from you guys.
Absolutely, you are awesome. And what about the ESA sample return mission by 2031? I mean, Elon will have landed several starships on Mars by then. Come on, ESA, a bit more ambition would be nice.
And if you're new to this channel and if you like our show, we would be very thankful if you would subscribe.
So then, see you next time.
See you!